This assessment asks us to draw a mechanism for the formation of this product under enzymatic conditions, meaning we can use generic acids and generic bases. The first step then will be to use a base to form the enolate. The base will grab this hydrogen, break the carbon-hydrogen bond, form the carbon-carbon pi bond, break the carbonyl bond to form an O- charge on our enolate. This will form our enolate with the O- charge and this alcohol. And we also have the phosphate group. This enolate will be our nucleophile and will react with the aldehyde with its own alcohol and phosphate group. 2-. The mechanism for this step will start with a lone pair on oxygen, collapsing down to form the pi bond. This carbon-carbon pi bond will act as a nucleophile to attack the aldehyde. Normally we'd kick electrons up onto oxygen, but since we're in an enzymatic environment, we can assume that we have some acid source to immediately protonate that to form the alcohol directly. Let's go ahead and number our carbons here, make sure we get everything in the right place. So at least as I've numbered it, carbon number 3 is going to be forming a bond with carbon number 4. We'll have our carbonyl on carbon number 2. We'll form the key 3-4 bond, and that will form our alcohol for our initial aldol addition product. Carbon number 3 still has its alcohol attached. Carbon number 2 still has carbon number 1 and the phosphate attached. Carbon number 4 still has carbon number 5 and 6 attached. 6 still has the phosphate. 2-. And carbon number 5 has the alcohol. Now notice we've flipped this molecule vertically, so now this alcohol on carbon number 5 will be on a wedge because the molecule has been flipped over. Okay, we're almost at our product then. All we need to do is the cyclization, and to do the cyclization, we'll use some more generic base. Some more generic base will grab this hydrogen on the oxygen on the alcohol on carbon number 5. This the oxygen-hydrogen bond electrons can go to attack carbon number 2 directly. That will break the carbon-oxygen pi bond. Normally we'd kick those electrons onto oxygen, but again, since we're enzymatic, we can use generic base or generic acid to protonate that oxygen, and that will form this product directly. So this mechanism under enzymatic conditions is how we will form this particular product.